Question 16. The ampere is defined in terms of, now this is straight from your definitions here, it's D, the force per unit length between parallel current carrying conductors. Now, I mean, these could be, especially this one over here, the number of electrons flowing past the point in a circuit in a given time. This could be, but this is your definition. You really need to learn that. 17. A battery of EMF 6 volts is connected to a 2 ohm resistor. The current in the circuit is 2 amps. The internal resistance of the battery is. So we have a battery, and it's connected to in a circuit here, and this is 2 ohms here, and it's got an EMF of 6 volts. Now if there's 2 amps here, actually it should be in that direction, if it's 2 amps, the potential difference across here would be 4 volts, because you would be using this formula over here, that V is equal to I times R. So it's 4 volts there. So there's 2 volts that have been lost. So we actually use this formula over here, that the EMF 6 volts is equal to your 2 times your R, your big R, which is your resistance in your circuit, plus your small r, which is your internal resistance, the resistance actually within your cell here. So you've got a resistance in there, and obviously we can see that your resistance must be 1 ohm, because 2 plus 1 is 3 times 2 is equal to 6. So B would be your correct answer there. Going on to question 18, we have, which of the following gives the resistance of an ideal ammeter and an ideal voltmeter? Now remember, an ammeter is always in series, and so we want all the current to be able to flow through that ammeter without any hindrance. So that must have zero, just a resistance of 0. So our ammeter must be 0, so we're looking at either that one. The voltmeter is in parallel, and so we basically don't want any current to be going through, or just a tiny fraction, so it needs to be infinite. So it's that one over there, so B is your correct answer.